For today's project, we will build the simplest possible neural network that can guess these simplified Tetris shapes. Now, in this video, I will explain how it works step by step. In the next video, we'll code it in Python. Because of its simplicity, there will be many limitations, and I will address those at the end. Right, because the goal actually is to demonstrate the core mechanics, how weights adjust and how predictions improve during training. There will be no machine learning jargon like backpropagation, gradient descent, hidden layers, like none of that, right? Right, let's just get into it. So what you see are our input images. We'll use these to train the network. However, we can't work with images directly, right? We need numbers. We need a numerical representation of these images. And fortunately, that is easy. These are black and white images, 3 by 3 pixels, and we can represent each one as a binary array, right? So black pixels became 0, white pixels became 1. So we've got shapes as numbers. Now the network needs answers. We don't want to upload the picture and get the answer like yes or no, right? We want to upload the picture and get the probability of what that shape could be. And let's have the answer to be between 0 and 1. And we'll refer to these as labels. So we have input, our shapes, and labels, one for each shape. Now we need 3 more things before training, and that is weights. These are the values we will be adjusting and tweaking during the training. So we start with completely random numbers. Like the weights you see here mean nothing, like they are just completely random. We just need something to get started, right? And we'll adjust these numbers many times during training, and eventually the network will find or learn the combination that can describe these shapes. So the final combination actually becomes our model. So I said we will be adjusting weights, but by how much? Well, that's exactly what learning rate is. After each prediction, we get a number, check it against our labels, and then draw a conclusion. If it's off, well, then we need to adjust, right? So the learning rate controls the size of that adjustment. So that's just important to remember that it's not the adjustment, because there is some equation involved. We'll talk about it soon. But it controls the size of the adjustment. And then we basically recalculate everything with these new adjusted weights, right? And how many times? Well, that's what epochs specifies, right? We use 1000 training rounds. Each round processes all 5 shapes, and by the end, it will have learned the patterns. So these are all variables, like everything in one view. Right. Let's go over the steps we have to perform each epoch during training. Each epoch follows the exact same pattern. During epoch, we process all 5 shapes one at a time. So we process one shape, get tweaked weights, then we use those weights for the next shape. And once we processed all 5 shapes, that's one epoch complete. And as you remember, we set epoch variable to 1000, so that is how many times all of this will repeat. And at the end, we get our final weights. Super simple maths. So first step, we take each pixel from our input and multiply it with its corresponding weight. We do that for all 9 pixels and sum them together. Now we use that number to calculate prediction. This function here with letter E, E is just Euler's number, right? So approximately 2.71. And all this function does, it takes the sum from the previous calculation and convert it into a new number that is between 0 and 1. So exactly how we defined our labels. If you remember, they also between 0 and 1. So then we can calculate error. We take the label of the shape we are currently processing and subtract the prediction. And this tells us how far off we were, right? And based on that error, we calculate the adjustment, and lastly, we add adjustment to weights. And that's basically it. So here you can actually see calculations. I won't go through this step by step. I just wanted to visualize it for you bearers, so you can pause if you want to actually see the numbers and like step by step. So first, calculate prediction, calculate error, calculate adjustments, update weights, and take these weights and go to shape 2 and again do the prediction and just repeat for all remaining shapes, right? And keep updating those weights. So I already have Python code, so we can basically do the training and see what are the final weights. So we did 1000 epochs, and at the end we got our final weights right here. These are our final weights. So now that we have final weights, we can do inference. And how is that calculated? Well, pretty easily for this example, and you are already familiar with these equations, right? We've done this before. So you take that guess, whatever the number is, and you compare it to your labels, and then you'll know which shape is that basically. So let's see if this actually works. I already have a code prepared, so let's see. Let's drag this T shape here, and let's see if the model can actually recognize and guess correctly. So yeah, I mean, as you can see, if you remember, the label for this shape was 0.5, and the model is predicting 0.48. So with pretty high confidence, we can say, yeah, the shape is T-shape, right? We can try one more. So we can do the L shape. And as you can see, it's basically the same story, right? So, I mean, it works. It's a very simple example, but it actually does something, right? So it's kind of practical. So you can see it actually do something. So I think it's pretty good kind of example for a beginner, for someone that actually wants to just get into the topic slowly. And we will code this in Python in the next video. So you'll have the full code, and the code will be extremely simple, and that's also the beauty of it. I don't think it's more than 100 lines. So it's going to be a quick video, but you'll have the complete thing. So let's talk about limitations. So first of all, obviously, we are testing on training data. So the network actually memorized these specific shapes, not maybe learn to generalize. Proper evaluation needs, needs data that model hasn't seen during the training. It's a single layer architecture, so only very simple things. If you need to recognize complex shapes, you're gonna need hidden layers and things like that. It's a tiny data set, right? Only 5 isn't really enough for real generalization. Obviously, when you're building like a proper machine learning application, you probably use thousands or millions of examples. But these limitations are like exactly why this is such a good teaching example, right? It strips away all the complexity and shows you like the core mechanism. And once you understand how this works, how weights adjust, how errors propagate, how predictions improve, scaling up to a proper neural network, it's just adding more of the same, right? The fundamentals stay the same. So I hope this helped you a little bit to understand how this works. Again, the next video we'll do a Python code, And in the future, we'll keep building. We'll make it more complex, and we'll see how we can what can we build, right? So thank you for watching. See you then.